Hey y'all, in the last lesson we talked about finding out where the middle of 2 points is. And in this lesson today we're going to talk about figuring out how far apart 2 points are. And so there's two ways to ask how far apart 2 points are. We could ask to find the length of a line segment. And the length of a line segment, and first of all, a line segment is just any piece of a line that starts and ends. So those are endpoints. And again, we talked about having a middle point, a midpoint. If we want to know how long that line segment is, what we're really asking is how far apart are those two endpoints? And so if we ask for the distance between the two endpoints or how long the line segment is, we're asking for the same thing. We want to know how long is this segment in the coordinate plane. And if it were horizontal or vertical, straight left and right or straight up and down, we could just count the units. But when it's slanted like this, when it has a slope, we have to do something else. And we already have a strategy for this that you might have learned in a previous class. If we sort of draw the path it would take us to go straight across and then up to get from one point to the other, we create a right triangle. And so we can find the length of this side of the right triangle, which is 7. And we can find the length of the other side of the right triangle, which is 8. And we had a formula for that. Maybe you remember, a squared plus b squared equals c squared. And so we can use this formula, the Pythagorean Theorem. I'll shorten theorem to THM, to find the length of that segment. The length in this case, the longest side, the side that's across from the right angle, we call that the hypotenuse. That's less important right now, maybe later, but it's good to know. That is going to be this value c. And so we can plug our numbers in for a and b. 7 and 8 are our a and b. It doesn't matter which one's which. And you could change c to d if you want to for distance. So I'm going to do that, d for distance, or L for length. But I'll use d for distance since that's the name of the lesson. And I can find the distance. So I'm going to do 7 squared plus 8 squared. And if you struggle with these things, we can go ahead and use the calculator. So 7, and then I'll press this a squared button, plus 8 squared. That's going to give me the left side, 113. And it's important to know that that 113 represents our distance or our length squared. So we got to do something to get rid of that squared. The opposite of squaring a number is square rooting a number. And so if we square root both sides, so if I square root 113, I can get the length of that line segment. And then we'll call it 10.63. I'll do 2 decimal places. That's pretty good. And you can see, since this is a decimal, how we can't just count boxes when we have a sloped line. So we have to use this formula. And so when we have a line in the coordinate plane or a segment in the coordinate plane and we can see it, we can just do a bit of counting. So if I look at this one on the right, I can draw the sides of the right triangle. And I can count how long they are. This one is 3 units. Vertically, I have 1, 2, 3, 4, 5, 6, 7 units. And I can plug into Pythagorean Theorem. And I think it's always a great idea to write it every single problem, and then you're reinforcing what the formula is. And I like to put the x value in for a. So the x value, the horizontal distance is 3. My y distance is 7. And I'm going to change c to d. And then I can go ahead and I can use my calculator, 3 squared plus 7 squared. Use the tool if you have it. And get 58, and then I need to square root that to get 7.6, And that 5 after the 1 is going to tell me to round the 1 to a 2, so 7.62. And it's a good idea to show this work and reinforce to yourself that you're going to have to do a square root. That's the biggest mistake people make, is they forget to square root once they've done 3 squared plus 7 squared. So you've done a really great job. You just missed one step. And so it's always important to square root there at the end. So if you practice that and write it down every time, you'll reinforce that, just like writing a squared plus b squared equals c squared every time. And so I can get, there's my x distance, that is 10. There's my y distance, that is 2. And so again, I like to put x first. I like to do the same thing every time. Just keep reinforcing the same processes every time. I can put 10 squared plus 2 squared in my calculator, and I would get 104. And then I want to reinforce that I'm going to have to square root at the end here to get my actual distance, or my actual length of my line segment. So square root of 104, and get, I'm going to call it 10.2. If you struggle with rounding, that's okay. You can write 10.198 or something like that. I'm not going to be picky about that. Just the process is important. So we'll call this 10.2. And there you have it. As always, let me just remind you that if you're struggling at all with this, or you need some help, please ask before it's too late. So ask as soon as the problem arises. So the other way we could ask to find distance, or how long a segment is we could just give you the coordinates. So we don't have the segment right here. We want to know how far apart these 2 points are in each case. And what we're really asking again is, how long is that segment? So another way to think about it, we're still going to use our a squared plus b squared equals c squared, but we're going to modify it a little bit. So if I go back to this previous page, the number I plugged in for x, or for a, was how far apart my 2 points were in the x direction. The number I plugged in for b was how far apart they were in the y direction. And we want to know how far apart things are. We subtract them. Each of these coordinates has an x and a y, if you remember from when we were doing slope or midpoint. And so to find that value for a, what I really did was I subtracted the x's. And to find the value for b, I subtracted the y's. And so you could just subtract them. It doesn't matter which order you subtract them in. Or you could set yourself up like we did when we found slope. And you can make a table with those values. So negative 5.8, negative 1.8. And now you can see which ones are x's and y's. I'm going to subtract the x's, negative 5 minus negative 1, and 8 minus 8. That gives me my 2 numbers to plug in, negative 4 and 0. And you could plug in the negative 4 or the positive 4 and 0, and then we could put this in the calculator. One mistake that could get made here pretty easily is the way that we plug negative 4 squared in. We need to put that in parentheses. The other thing that we could do is just know that there's no such thing as a negative distance. So when I do that subtraction and I get a negative number, we could just get rid of the negative and plug in positive 4. Because what all that negative 4 is telling us is there's 4 units in the x direction between our points. So this distance right here in our new problem would have been 4. So we could ignore the negative in this case. And we'd get 16. And again, that is d squared. And so we can square root both sides. And when you square root 16, you get 4. So this is just another way to think about it. When you look at Desmos and you plot points, you can also see the points. And if you see these 2 points, well, they're straight across from each other. And they were 4 units apart. So those 2 ways to find out how far apart they are. So let me go ahead and do one more. Remember, I have an x and a y, an x and a y. I'm going to write the formula every time. We've modified this formula to remind ourselves, hey, we get the a and b by subtracting x's and by subtracting y's. So I can go ahead and put these in the calculator. I'm going to do that quick. So I went ahead and put my points in, and then I subtracted my x's here, and I subtracted my y's. And I got a negative 11 for the difference in my y's, and I'm just going to plug in positive 11 when I square them. So I have 15 squared plus 11 squared, and I get 346. And it's important that you write this stuff down because you're going to keep reminding yourself, you're going to keep getting to a point where you have a squared here, and we have to get rid of that by square rooting. We don't want to forget to square root at the end. The square root of 346, we'll call it 18.6. So what I want you to do right now is I want you to pause, and I want you to find the distance between those 2 points. And then I want you to press play and check your answer against mine. And if you didn't get it the same, I want you to raise your hand, and I want you to ask for help, and we can see where maybe you made a small mistake. So as always, I wrote our original formula, then our modified formula. Just keep reinforcing to myself that that's what we're using. I subtracted my x's and got 1. Subtracted my y's and got 6. I did 1 squared plus 6 squared. I could plug that straight into Desmos to get 37. And then I always have to remind myself I got a square root at the end, and I get something close to 6.08. So if you didn't get that, and you can't find the mistake that you made, please make sure that you ask. Please make sure that if you have any questions, you ask for help. Stick around and answer the questions. If you get stuck there, ask for help. As always, ask for help. Take your time on these, and good luck.